Hey everyone, you got Peter Estes here with Valley CAD. Trying out another live stream here. We've actually been pulling an all-nighter today, almost 5 o'clock on September 28th here. Yeah, I've been pulling an all-nighter. Got several designs to get done, and on top of that, we're running quite a few items on our CNC machine, and so I've been running that all night as well. So it's been a pretty long day actually. So like I said, we're doing a live stream right now, trying to do a couple designs here, and thought it'd be kind of fun to show you this one that I'm working on. So it's a simple plate that I'm working on right now, but it's not just any sort of plate. I was actually contacted and was told, hey, it's someone that lives down in Marina del Rey actually, and on their boat, they are needing to replace, they're called Bayliner seats, and they recline and so forth, and so they wanted to get some brackets made for where the seat goes, and that's what you see here on these pictures. And so they sent me some information on it, and I'm checking it out right now, and wanted to see if we can get a design done tonight at least to send off to them, or I should say this morning, send it off to them and see how we're doing here. So stick around. If you got questions, as always, feel free to ask anything, and we'll be rocking and rolling here. So sit back, relax, and have fun. Alright, so this is going to be up on my, the picture is going to be on my other monitor so that way I can see SolidWorks here. So I was given some information saying, I'll pull the picture over actually. I was given some information saying that these holes that we see here are where the brackets need to get mounted onto this plate that's on this boat, and was told that the spacing from this hole to the other hole is 28 inches, and 14 inches in the center, and they're 8 inches across from each other. So I'm going to use that information. They also gave me some information on how they can make the angle irons that I'm making fit. So here we go. So what I did was I took that picture and kind of made my own holes on here, and what I'm in the process of doing right now is coming in and specifying that these guide rails need to be actually 30 inches, and with that, these are going to be the paths for my weldment profiles I'm going to be putting on here. It's going to be actually angle iron profiles. So sit back, enjoy the music. I know I say that every time, but sit back, enjoy the music, and if questions pop up, feel free to ask them. So what I just did there is I came in and made this center line and that center line equal to each other, and because I did that, I'm able to come in and just put in a 3/4 inch dimension here, and that's going to fully define my sketch. I made those two horizontal lines based off the center of this vertical center line that was off of my cut extrude 1, and I gave it overall distance of 30 inches. So we'll see how that works out for us, and we'll say okay to that. So like I was saying, I want to come in and do weldments now. And with our weldment, we're going to do a structural member with that. And let's do ANSI inch. And we want to do angle iron. And probably square ends. So on these angle iron that my client is specifying that they would like to have is 1.5 by 2.5. So let's see if we get it. Have something like that. There it is. Probably set up where it's 1/4 inch thick. Come in and grab that line there. That looks good. And with that, we'll say okay. And what I'm gonna do next is just come in and I would mirror that body over, but it looks like I need to make it to where the plane that I would need a mirror about comes in the center. So before I mirror it, I need to come in and do a reference plane. I just simply click on that point there, and let's click on this face here. And what that's gonna say is, hey, make it so it's parallel to this face. Now I could also come in and say, oh, I should probably make it so it's parallel to my right plane. That might be a better aspect to go, because if I ever come in here and change the face later, it might cause issues. As compared to doing it on my right plane, that is not going to change at all. So that's why I'm coming in and specifying right plane instead. Okay, so now that I got that plane there, simply come in and mirror. We'll go off of that new plane that I created, and we'll do bodies to mirror, and we'll select that body there. And we're done. Pretty cool, right? So looking at this, that looks pretty good. Not bad. So before I just did that mirror just to verify everything. Before I even do the mirror though, what I would want to do is come in and create holes on this angle iron. Just hang on really quick, just reviewing my notes for a second here. So I'm going to come in and do a simple cut on this, and we'll set it up to where they are slots. I might need to bump this over just a little bit more. Oh, that was a little loud. My hole here, coming off from this edge here, it's 3/4 inch, and it's doing that over here as well. But I should probably bump that 3/4 inch just a little bit bigger. More likely, probably bump it up so it's 7/8 inch. There we go. It's gonna help center this over those holes a little bit easier. And so now what I'm gonna do is come in, do a cut on this face, and we're just gonna do a simple slot. And with that slot, I'm going to come in and center it over this face here and do it kind of like that. I'm just oversizing the slots right now so that way I can come back and grab it a little bit easier. But I'm going to come in and make every single one of these slots equal to each other. There's no need to make them different, right? So we'll just say equal slots. And size of them does not need to be that big. So what I'm going to do is simply come in, do a smart dimension, and we'll just say from there to there, we'll just make it so it's 0.75. Once again, it's just there to kind of help the assembly process. Probably would be able to get away with it not having to do having to do slots, but you know, I always when I'm not on site and seeing what the true parameters are, and I'm working with components that I'm not seeing in person, I like to give little slots, and the client can come back and say, hey, those are a little too big, or so forth, and we can update that as needed. So part of the fun of pulling an all-nighter designing and so forth, I am also running in like I'm at my home office right now, and we got a tabletop 3D CNC carving machine, and currently I am running a program on that CNC machine, and all is coming through and cutting slots. It's kind of fun. We're making wooden letterboards for a company, and I got to make 120 of these, and roughly it takes about 50 minutes per board on the machine. So yeah, I gotta basically run that machine 24 hours a day to meet our deadline, because I gotta turn it in about 15 days, I want to say. And so yeah, I am so blessed and thankful for this, but man, we got our work cut out for us right now. All right, so going back to this, what I wanted to do is say 0.5 plus 1/32. Okay. So now all these slots are fully defined. So remember, I did that mirror function first, right? I'm sorry, before I get into going back into that mirror, what we're gonna do next is we're gonna do cut through all. Now, you might be thinking, well, if you cut through all, it's gonna cut through this bottom plate, right? Well, because I'm doing a multi-body design, multi-body is a fantastic way of modeling. I do it all the time. It's a intermediate step before you have a final solid body. It's kind of you kind of treat your part file like an assembly. And I've done several YouTube videos regarding sheet metal and weldment applications, and with that, SolidWorks is intended to do weldment applications in a part file. That way you have a cut list and so forth. So I like still doing it even if I'm not doing full-on weldments. I will do intermediate steps of doing multi-body design. And part of the reason for that is something like this. I want to have these slots, and I want to have them cut through this angle iron, but not this bottom plate. So whenever you have multi-body design, you have feature scope. And within feature scope, you could come in and say, hey, I just want to cut through that body alone and nothing else. And so when I say okay to that, and I'm saying through all right now. So when I do that, you'll still see, oh, look at that. It only cut through this one body. So that's what I generally like to do. All right, so now that we got that, check out what happens when I go back to my mirror function. So I'll bring in my plane again, bring up mirror. Because I put the cut before the mirror, it now includes that. Because whenever you mirror bodies, it includes everything that's a part of that body. So if you're not totally familiar with the strategy of how SolidWorks goes, you have a sketch. So you always start off with a sketch, no matter what. That sketch then gets absorbed into the feature. And features come in together and make up bodies. And those bodies can then make up the part file. And so that's kind of how the structure of SolidWorks goes, and that's how the design tree can also help you out as well. So because I got it set up with multi-bodies, you'll see also I have a cut list because I applied a weldments function. So now that we got that set up, it's looking pretty good, not bad. So the next thing that I need to do is come in and make it so that I'll pull the picture over here so you guys can see it again. So the type of seat that's gonna sit on this, it's a seat by Wise. Wise. I don't know. They're just called Wise, and so they make seats for like marine applications, golf carts, industrial applications. So this given seat is actually a Wise Bayliner Capri series. And so what it is, it's a back-to-back lounge recliner seat. And so I'll just show you on their website right here. Gotta say this video is not sponsored by Wise, okay? Just Putting it out there, disclaimer. So this is the product here. This is the actual seat. And so how it works is it'll be in a back-to-back application, and then these two backs can actually separate from each other. And when that happens, it goes into a flat state like this. And this is how it looks when they're collapsed. So this is the bottom view that we're looking at. So that's what the Bayliner does. Okay. So now going back into this, I need to make it to where these bars fit into the guide rails here. And I'm still kind of thinking on how we should go about this. I'm almost wondering, like my client's asking for angle irons. I think we might need to go with a C shape, but we'll find out. So sorry, just reviewing my notes for a minute. And also double checking to see how my machine's doing. Looks like we're still chugging along, so that's always good, right? All right. I don't know, whenever I do live streams and I got like a recording studio here at my home office, because I also do a lot of music applications, so I'm using my recording studio right now and talking into a microphone. Kind of feel like I'm doing like NPR sort of stuff, and you know, this is slow jams, you know, like something like that. Sorry, getting a little weird, and like I said, I've been going for almost 24 hours straight and living on coffee right now. All right, so the notes don't really make sense to me right now. But ultimately, like, we got that rod on the bottom of the seat, and that rod is needing to ride in this area. But we also need to make it to where the rod does not fall out. So, just looking at this a little bit more. I'm almost to the point of wanting to model up the seats, but not sure how we could go about that just yet. I might have an idea. So you're gonna see some tracing applications right now. So here we go. So let's open up a new part file. And let's go on our right side plane, create a new sketch. And with that, we're gonna do a sketch picture. And with that, let's come on over to Valley CAD. So this is the picture that's from the website. So on their website, they say that the height of this is 19 inches, width is 20, and depth is 46. So seating depth is also 16. So I'm gathering that from here to there, 16. But what I want to look at is our height. So I'm going to say from here, and we'll say vertically up to there, and we'll call that out at 19 inches. So what I just utilized was my enable scale tool, and what that does is it will take a line there, and it will you can angle, like rotate your image if you want to, but what it is, I took it to the bottom, brought it up to the top, and said make that line 19 inches. Pretty cool, right? So I'll come in here, I'll just make it so that this is about centered and say okay to that. All right, so what I want to do next is come in and trace this and make my first seat cushion. Okay, so whenever I do sketch picture, I always do that in a separate sketch feature than my actual extrusion. So now that I have that sketch done, I'm going to come in on my right plane again, create a new sketch, and with that I'm just going to come in. I'm not going to be very accurate with it. I'm just going to come in and say from there to there. You know what, we'll do it this way. I'm still thinking as I'm going through it. Now I'm looking at this going, you know what? We need to make this into a true assembly file. So what I'm going to do is come in, make this the back one part file, and make this another part file. So we'll do that, and we'll come in. I'm just kind of getting it close. You know, my biggest thing that I needed was make this so it's 19 inches, like that. Cool. All right, so now we'll come in and trim this. We'll do power trim application. See how my machine's going. So it's almost done. I'll probably be done in the next. Oh, I'll wait till that's my end line when it comes over that way. So it's not done yet. It's probably got a couple more passes to go. Okay, so now we have that. I'll just go in and fully define this. We'll say that that's at 4. And I just heard my machine die down, so that means that it is done. Yes. So that's at 4. We'll say that this guy here is at 14. And this one will be at 5. Great. But we're still not fully defined. Why is that? It's because of this line up here. We'll call that out at 4.5. Cool. So now we got that. I'm just going to take that sketch and do a feature, boss extrude, and we'll do a mid-plane application. And with that mid-plane, we'll come in and the width of it is 20. So we'll just say 20 on that, mid-plane, done. Cool. So now that I have that, click save. And I'm saving this over onto my other screen for a second here. As you hear me clicking away. All right. So now that I have that, the next thing I'm going to do is simply come in here, File, Save As, and we'll do Save as Copy, and we'll do Save as Copy and open it. And this is going to be the cushion of seat. I'm probably spelling cushion wrong, but we'll find out. Okay, so now that this is cushion of seat, I'm going to come in here, edit the sketch, and instead of having it like that, I'm just going to simply come in, make that into a construction line or construction line setup, and we'll come in here and we'll make this into a new set of lines. We'll find out how I do here. believe that this was 16, the seating depth. So let's see what that looks like. Looks like that. All right, and we'll give it a little more thickness in that. It's probably more at the 4-inch thickness, and we'll tell you to be horizontal. Yeah, once again, it's blocky. It's just meant for representation of the seat cushions. So we'll say that it looks good, and we will simply click save on that. And I'm going to hide this picture. Great. So Control Tab to go back to my original one. We'll hide that one too. And now what I'm going to do is save this. We'll come in and do a new assembly here. So I'm going to actually go off of my seat cushion, make assembly from part, like so. We'll say cushion of seat, and we will lock that one in place. Now what we want to do is assembly and insert my next component in the back of seat. So because I did a save as copy, these guys are identical right now. Now what I want to do is make it so that this is flexible, or I should not flexible, but make it so that I can rotate it. So I want to make it so it can float. So what's going to happen now is I want to make it so that the plane, so my right plane and right plane are coincident, but I still want to make it so that this guy can pivot, right? So what I want to do now is come in and I will say that this edge and this edge are coincident to each other, like that. Now what I can do is take this and flatten it out. Okay. Now this is going to be, it's not flying out as I would like, because technically what's supposed to happen is this is supposed to slide out, and as that slides out, this will move with it. Let's look at the bottom picture, see how our mechanism looks. Pivot there and pivot there. So it looks like there's a plate underneath. So maybe instead of locking it like that, take that and we'll delete that. Because like I said, when this is flat, it should be something like this. So what we'll do is we'll come in, we'll make these two coincident, like that. And when it comes up, that should technically be vertical, like so. Okay, that, it should work. All right, so now what we'll do is I'll just simply take this, take it over, flip it over, and we'll make it to where these two guys are coincident, because that's our hinge point. And we'll take it so that my right plane and right plane are also coincident. So now we can see that these guys are going to be coming out, and as this comes down, should be pretty good. So now what I want to do is check this one out. So what I want to do is take that, copy it over, flip it around like so, and same sort of application. I'm going to take this edge here and make it coincident to this edge here, like so. Yep. And we'll come in and we'll take our right plane. Just realized our music died. Let's do that. So now that we got that set up, right? I want to take my right plane of this guy and the right plane of my assembly and make those two coincident. But then what I want to do is take this face and this face, make it coincident as well. but you saw how it kind of just freaked out. Not a big deal. So as this flattens out, so we'll be making it kind of like that. And so what I could do next actually is come in and do another mate. And what I can do with this is say, let's do a mechanical mate. And what that will allow me, or sorry, not a mechanical, we want to do an advanced mate. And we want to do a max and minimum angle. And we want to do it between these two faces here, this face and that face. So we want our minimum to each other to be 0. Like that. But we want our maximum to be 180. So let's see what that could do for us. There we go. Whoop. So it's a little mad, but maybe we can make this work. Maybe. There we go. I don't know. It's being silly. Once again, I don't care that they don't technically look like seats. It's just for physical. It's just a representation thing. Okay? So now that we have that, this guy is going to be a little interesting. Be cool if there was a way to make it to where I'm just looking at how the movement of it is. Seeing if there's a way. Let's see. Maybe I could come in, do a mechanical, advanced mate, and do a max min angle between this guy and the top plane. And what that will do is say the max that I can, or the max is 90, and the min is 0. Maybe. I wonder if it's due to this other mate. That one there. So let's suppress that. Just trying to see if there's a way to make it to where that'll work for me. You know, so that's always a fun thing. Yeah, sure. It's, I don't know. I'm weird. I enjoy this sort of stuff, trying to make it function as I would think of it to function, even though it is not. So let's do it. Let's flip it. Let's say 0, and the minimum's 90. Nope, that's not gonna do it. It's just gonna be a little funky. So what I'm gonna do instead is have it in a add a configuration. I'll say folded. Add another configuration and say extended. So here's our folded and extended ranges. Folded range is gonna be like this. We'll delete that. Yes. So I want to come in and make it to where this face and this face are going to be perpendicular. So that's how it is in the folded state. I'll just need to come in and I want to unsuppress that, or suppress it. Unsuppress it, and then I want to go to extended go to mates, and we will suppress it this time. And now what I'm going to do is say make this face and this face parallel. So now check this out. I added a configuration toolbar here, and so I could go to folded state and then go to extended state. Done. Okay. So now that we have that, we'll simply click save on that, and we'll just call this guy cool. So I just saved this as a sub-assembly, so what it's actually gonna be, because what I want to do is come into my part file here, and we'll save this out next. Sorry, excuse me. Okay, so the seat bracket, now we'll come back over here to file, and we will make an assembly from this. Okay, so make assembly from part, that assembly right there. Cool, we'll just drop this guy in and make it so it's fixed. And now what we're gonna do is insert my, my seat assembly. Wow, all right. So these seats are obviously quite a bit wider. So what I want to do is take this face and that face, that face, and that face, and say make a width mate. And what I want to do next is come in, add a configuration, and we're going to call this one extended. Add another configuration and call this one folded. And the reason why I called it this way is because I called that on my subassembly. And I always recommend keeping your, if you're going to be doing configurations with assemblies and so forth, to keep the same naming structure. It just makes it so much easier. So now when I come in here, I see my extended is now set up, but I'm under my folded configuration of my main assembly. So I'm going to switch that to folded. So now when I switch from folded to extended, it matches to what my subassembly is as well. Pretty cool, right? I know. Okay, so with that, we'll just take this. So I made it so where it's centered about my plate here. Now, one of these are going to be locked. And let's see which one that is going to be though. I'm going to be right back. I'm going to go swap out boards on my CNC machine to get cutting on the next one. So stick around. I will put this up so you can actually, while I'm out there moving the machine around, you can actually watch it on the screen. So once again, I am going to step away from my computer for a minute, but please don't go anywhere, even though no one's here yet. All right, hang on. Alright, so got the machine up and running again, as you can see on the screen. So let's get back to our designing here. Alright, so more likely one of these seats, bottom ends, gets locked in place. Let's take a look at this. I wonder which one it is, actually. I am still here. I'm just doing a little, just processing this, trying to figure out, alright, maybe, almost looks like both seats can actually, like, slide out. So, that's very interesting. So, looking at this, so, it's almost as if like I need to figure out where these rods sit. Let's see here. I'm almost thinking that we need to come in and put in another L rail up here and over and make it probably 2x3, give or take. They told me here that the rods are 1 inch diameter, 11 3/4 inch wide. Okay. So let's come back to our normal part file here. So what they're saying here is when I believe it's when a seat is in a folded state that the rods that go across are 3.5 inches apart from each other and 27.5 when it's in a flat state. And I'm talking about those rods that went across. So let's just go off of this here, and let's say we come off of our one of the things I'm thinking through is send it up to where, probably not on this, but like create a larger rail and come on this here and say, all right, it needs to be where they are 27.5 inches open and 3.5 closed. So create a stop here that's 27.5 inches from side to side, and another one that's 3.5 from each other. So what I'm kind of thinking here is we almost, I don't like the idea of doing an angle iron and bolting another angle iron on it. The other option that I would do is a C channel, and with a C channel come in and we'll say C36. Let's see what that looks like. Yeah, but that's not the type of C channel I was hoping for. Yeah, it's a T channel. Don't want that. Yeah, these sort of channels are way too way too robust. It's a little bit better. Guess the other options that I come in, like how they want it on their notes. 9 degrees, 2 inches by 3 inches tall. So if we go at that rate, what I'm going to do is this. We'll come off this face here. Let's see here. I'm probably gonna have to offset that line, but let's see if I can actually move it around or not. Yeah, more likely I'm gonna have to do that, but let's see here. Yep. So let's do this. That might work. Alright, so now we got those two angles on there. What we're gonna do now is come in and cut out those slots, that way the rod will fit through that. So we know our two measurements are at 3.5 inches and also at 27.5 inches. So what I'm gonna do this time is, before doing my mirror again, come in and more likely I'm gonna come in and cut these out. So let's see. So I'm going to come in and do a centerline application and making it centered about the part. And what that's going to allow me to do is, when I come in and smart dimension this, if I come here, select the center line, move to the right, SolidWorks will automatically do the double of its dimension. And so what that would be is 3.5. And then I do that again here, and this time will be 27.5. Okay, so now what we want to do is take these two guys, make them equal, and with that equal dimension, the rod's about 1 inch in diameter, so we'll just come in 1.0325, so let's bump it up a 32nd of an inch. Now, one thing I'm working through here is, do we come in and we come in and cut this, and do they want to make it to where they have to pick it up, slide it out, and then drop it back down? So there's a couple ways that we could go about this, actually. What I do want to do, though, is come in and looking at the pictures on this, I'm not sure how much further down these bars are to the seat. So to see how far down I should make these holes, we'll just come off here for right now and say, make it come down 1.5 inches. And I want to come in and make these two horizontal, like that. So now these are fully defined, and I can mirror these two holes onto the other side through my sketch or via 3D model. In this application, I'll just do it inside the sketch. Grab those two circles. I had that construction line, and there we go. So now we have that. We say, okay, let's cut through all. And this time with through all, I want it to go through both bodies. I want to say all bodies because it's not going to hit this bottom plate at all. So now the next aspect to look at is, do we want to make it to where it's a slot that comes down on each area, and that way you pick up the seat, you pick it up out of its slot, slide it down, and you drop it? I'm wondering if that's ultimately what they would like, or would it be better to come in and come at an angle, so that way when you're doing this, then you slide it down. That way, you know, this is for a boat that's out on the ocean. You know, you gotta deal with waves, and so I'm wondering if we make it to where the slot goes out like this, comes over, and then comes down. We can see what they have to say about that. I think that way will work. Kind of doing a angled aspect there. So we'll come back in, we'll edit our sketch here, and what I want to do You know what? We'll make a new sketch and we'll just come in and cut in case they want to change how the grooves are for the rods to flow into. So what I'm gonna do is simply do a slot command, and we'll do center point style, and we'll come off. Oops, I want to do that one. Come off, and we'll just come off at an angle, like so. I'll make this guy and this guy concentric, or actually co-radial, and with that, we'll say coming down at, we'll say 45 degrees, and then repeat that on every single hole. So we come in here, slot, do that same style slot again. And I could come in and say, hey, make these two guys equal to each other, equal slots, and make it to where these two lines are also perpendicular, because it's come off at 45 degrees. So my reasoning for this is you pull out the rod, it comes up, you slide it down and it hits the next spot, and then it will slide down into its next catch hold. And what's kind of cool about going at an angle like this is the boat, as it goes on over waves and stuff, it could get a vertical jostle on it. But now by going at an angle, it's gonna have to go up, and as it hits its top edge, it's gonna try to push it in and should make it so it's a little more rigid. Hang on again. All right. So we'll come in now and we'll make these two guys horizontal. Oh, not horizontal. I want to fully define this. Let's say that goes up half an inch above it at all times. So kind of like that is what I'm thinking. We'll see what that could do for us. So in this application, I'm just gonna mirror it over because I didn't have a center line there. So mirror plane, we want to just go off of our front plane there. Features this time, I just want to mirror that feature over. All right, full preview. Selected feature cannot be pattern using geometry pattern. Deselect. Okay. Huh. Not a big deal. We'll just do this. We'll go back into the sketch and I will mirror it over. So we'll just simply do a center line, go from here up to the top. And then with that, we just simply do a mirror function within the sketch. Entities are those guys minus the line, and we want to mirror about the center line. There we go. I'll just cut through all. Cool, not a big deal. So now the next thing is do the mirror function, and we should be done. What we will need to do is come in with holes that will bolt onto each one. Let me just review my notes again here. So because I made these slots equal to these holes, all I need to do is come in here and say, you know what, let's make this hole a little bit larger, 1.125. Do a control Q. It's gonna update my slots and everything. Pretty cool. Okay, so now what I'm gonna do is come back before the mirror, and what we're gonna do is come in and do simple holes here as well. So do cut extrude, and I know I could be using Hole Wizard. I'm just not at this time. but I think I will now. Sorry. I am a little tired right now. Let's see here. Our machine is still running just fine. So let's go on to this face here. We'll do Hole Wizard. And what we're gonna do is a clearance hole, just standard hole there. And what we wanna do is make it so that it is, we'll just do fractional sizes, and we'll set up so that 3/8 bolt, so we'll say 13/32 hole, and we'll say through all and position. What I'm gonna do is simply come in and we'll make it so it's a square pattern. So coming in here, we'll just do square, square. Drop points on each corner there. Have to delete that one in the middle though. Okay, and we'll just come in and make it so that this is going to be about 4 inches by, we'll say 1.75. Too much. Cool. And we'll just come in, do center line from the center of this face. Make these guys horizontal. And so with that, we're saying, okay, that looks good. But the next thing is I want to say how far off from these edges are these. We'll just say it comes in at 5 inches. Now we'll do another center line. And we can simply mirror all these entities and mirror it about that. Fully defined. Need to drop some points on there, I guess. Not a big deal. There we go. So now we got holes that are lined up on each other. Should work pretty well. Now we'll come back into our mirror function, and now we're done. So like I was saying, the purpose of these holes and slots like that is due to the fact that the boat is gonna go like this a lot. And if instead of having this going straight up and down, because that will happen, being able to come in and say go at an angle as this comes up, you know, if it hits a wave, it's gonna have another angle to say, hey, let's not just go straight up, let's push out, and that's gonna cause this to not pop out as easily. So hopefully that will solve the issue for them. Once again, I'm not sure how far down these should go or are able to go. So I don't know how far down those rods are in reality. So we'll simply save this and we'll do save all. Yep, rebuild and save document. Let's hop it over to my other screen. Cool. All right, so now we'll just come back to the part file here. I'm gonna hide some things. We're also gonna hide that. We'll project off of this. Okay, so I'll just come in here and hide these sketches really quick. Let's do that here as well. Okay. So now what I'm going to do is go back to my part file since this is a weldment. More likely it's going to be made out of aluminum. So we'll just say 1060 alloy on it. Control Q. Say update automatically. Come in here and edit my units here. So we'll just see these two guys here. Interesting. Technically, this should be a different... I don't know why it's including that. I think SolidWorks is being drunk. Technically, this guy and this guy should be the same. This one and this one should be the same. Not totally sure what's happening here to make it not function properly. still awake here. Silly SolidWorks. Oops. I'm sorry, I'm falling asleep here at the computer right now. Probably gonna have to call it quits here and go take an hour power nap. And let's see how our machine's looking here. This should be done in the next 5-10 minutes. That's good. So I'm probably gonna end our little live stream right now. Got the design done. Send it off to the client, see what they have to say, see if they want us to change anything on it, and we'll go from there. All right. Thanks for hanging out with us. Have a great rest of the day, and make sure you learn something new. See ya.